Oh, I should stop the recording. Is that cool with everyone? All right, so Renee, you may have seen Renee roll into town with his overloaded van to pull out some copper and make some bracelets or some toolboxes or some of the wood projects that we do. He's our lead on our Skills Ready initiative, and he does some pretty cool things in terms of fundraising and granting. And if you haven't got a metal machining program yet, you really need to talk to this guy. He's got machines, but he's got some connections. He's got some cool things going on. And I'm also going to introduce my colleague, Jesse, who is really the creative mind behind everything you'll see today. Jesse came about because her and I were at a VICA event, which is the Vancouver Island Construction Association, and we were the only two sober people in the room. And we started a conversation about what we do at the foundation. And she's like, oh, I'm a teacher. And I said, that's nice. What do you do? She's like, I try to do applied learning as much as possible. She's also a boat builder, although not a formal apprentice, because technically it's like not a new school apprenticeship. We're still working on that one. I don't know, Jason, do you have influence over that one? Is wood and wood boat building coming back as an apprenticeship? Yeah, I didn't think so. There's only like 3 of them. 2 of them are on this phone call. There's that. I'm suddenly realizing how many people either work with us or on Skills Ready. I'm also going to introduce my colleague Shane Roy, who's up in Fort St. John. He's part of our All Roads project, which supports First Nations communities on workforce development. But he's also the person who leads the. He rolls around with a truck full of small engines, and he'll teach your kids how to take them apart and put them back together. He'll also do driver's training if you know anybody who needs a little bit of help. I kind of shouldn't offer that, but if you do need driver's training, we have a grant for that, so give us a call. I also want to introduce Megan Rosso, who's our communications. I'd like to think of you as the communication person extraordinaire, but I know that's not your official title. Megan joins us from, where are you today?
I'm in Surrey today.
Okay. So Megan's joining us from Surrey today, and she is the creative eye behind all the promotional stuff you saw with this. I'm just going to keep going because we also have Randy Gray, who's kind of joined us as, I don't know, are you officially, we should talk about that later. But Randy was looking for something to do in life, and I was like, you want to help us build an elementary initiative around ADST and applied learning, and maybe do some tools and get people to think about design thinking. And he's like, I've got it, just set me loose. So I think, where are you today? You're in Vancouver teaching UBC students how to do design thinking?
Yeah, I was at UBC teaching design thinking to the tech ed students, and then it was open. I had student teachers from biology, physics, creative arts, yeah, and another session.
Very cool. So yeah, we're working towards seeing if we can bring some more resources to the people who are going to influence kids first, so that by the time they get to high school, they just expect that shop class is the thing that they're going to do next, as opposed to trying to convince them in grade 9 that tools are cool. Oh, that sounds cool. We should have a tools are cool initiative.
And hats, please.
And hats. Oh, I do need a new hat. So we're here largely because the ITA, Jason and Lisa and Maureen were like, we need to do something cool. And I was like, we got this, could we do this? And they said, maybe. And then they said, okay, fine. And they allowed us to take the time and put the creative energy and bring industry together to come up with some trades projects. So I want to shout out to Jason and the ITA for enabling us to do that, because it's been a lot of fun. Although I do have blisters, because apparently I don't know how to strip wire. Which is the strangest feeling I've ever had. Like wire stripping blisters, not like any other blister I've had. So yeah, I've rambled on far too long, but so I'm gonna jump right into it. The whole purpose of what we're doing is trying to figure out ways to use hands-on learning to introduce tools of the trade and get people excited about learning, and more importantly, excited about getting out of their house and maybe pursuing a trades career down the road. A large part of our focus is on introducing trades careers as something that anybody can do. So normalizing trades not as a job that your neighbor does and maybe your cousin does, but also that people you didn't think would do them do. And also trying to promote this idea that if you don't see yourself in the trades today, you might see yourself in the trades tomorrow. And here's some people who you may relate to. So a lot of it is about highlighting the fact that building things is a pretty empowering experience. We know that not all teachers are comfortable using tools, so a lot of the projects you'll see today are about helping those teachers who may not themselves ever have stepped in a hardware store feel comfortable taking tools into the classroom or even talking about trades. So as we go, most of you are well aware of trades programming, so I'm not going to hark on that too much, but I am going to say, like, this might be a nudge to your staff room friends who could potentially help you in 5 to 10 years with some shop class recruitment. All right, we're going to jump right into it. Today's theme is electrical. For those of you who have not recently looked at the ITA trades programs, we're talking about 4 main trades today: the construction electrician, industrial electrician, instrumentation and control, and motor winder. Those are our big trades, so you'll hear reference to them every once in a while as we talk about lemons. One thing I am going to post in the chat is a link to sign up for mail-outs of the book that we're going to talk about when it's finally printing, as well as any of the digital resources if you'd like a copy, as well as notifications of upcoming things. So please take the time to fill out the SurveyMonkey for that so that we know how to get a hold of you. And if you think someone else in your life needs to fill it out, send it to them or fill it out on their behalf. I'll email them and throw you under the bus. Without further ado, this is the part where my technical skills get challenged. Jesse, did you want to talk a little bit about what the elementary electrical project is?
Yeah. So the entry to electricity for elementary is what is also going to be the book that we're printing, the hard copy. And I'm pretty excited about that to come out. So those projects can be accessed also on our Skills Ready website. And I'm going to be showing you a bunch of them today. And yeah, they've been in development for a really long time, and I'm super excited that they're almost ready to go. Oh, there we go. Electricity for elementary. So part of what we were thinking was that if we can tie it into the BC curriculum, we can convince teachers to introduce this stuff and the tools that electricians use and techniques and skills that they use, and make it as an excuse to cover the BC curriculum so that we get buy-in from the teachers. So for example, grade 1, you've got kids learning about specific properties of materials, allowing them to use them in different ways. So talking about what's a conductor and how can you use a piece of fruit to make a battery? What is it about this fruit that is electrical? Grade 4s talk about energy having various forms and devices that transform energy. So all of these projects are little devices that transform either kinetic energy into electrical energy or chemical energy into electrical energy, and back and forth. Anyway, there's lots of different ties to the BC curriculum, and all of these projects have strong ties to that. Yeah, should we just dive into some of those projects? Right, okay, so these are mainly for elementary and middle school teachers, or any instructor for beginner learners of any age, actually. Just if you're looking for something simple and fun and safe electrically to do with your students. And one of the coolest things that we're going to talk about is like the mysterious and magical relationship between magnetism and electricity too. So here's one of the wide range of projects that we came up with. So this is called the Bright Bracelet, and it ties in really well with the grade 4s, the devices that transform energy. And they make this stainless steel thread, conductive thread now, and you can actually sew circuits into textiles and make your own wearable LED light up art. So the kids are learning how LEDs are, they've got a direction to them. They're, if you put them in backwards, they don't work. If you hook them up to a battery that's too big, they blow out. There's lots of different little lessons that you can learn with sewing this little thing up together. And they're all sewn in parallel. So you can talk about parallel and series with them if you want to. Yeah.
Just take this moment to also highlight that a lot of these projects you're going to find on our website. So if you haven't been to the project's website before, You'll see it here. It's projects.skillsready.ca. And you can hop on there and see a lot of these projects already up. So the Bright Bracelet is there with some process pictures down on the side in terms of that layout that teachers might want to might try to be figuring out on their own and may not have done this before, talking about the positive and the negative, and then that's that flow that Jesse was talking about. So if you are looking for more on the project that we have and looking for some guidance through it, or want to share that with a close, like a colleague, definitely referring to the website would be a good starting point.
Awesome. Thank you for showing that. Next, the lit up LED. Oh yeah, this one's really cool. This is about as simple as it gets. This circuit is just an LED put over a coin battery, and the LED lights up, and you can do anything you want with it. In this example, I did a little origami blow up balloon, and you actually put the light inside it, and you can bop it around the room. But there's so many different options. This is a really good one for grade ones, learning about the different materials and properties of different materials. But you can put that in little crowns, hats, tiaras, in shirts. You can put it on toys. You can get them brainstorming about different problems they can solve in their life. Someplace it's a little bit too dark. Where do you put this little light? Super basic. That was one of the challenging things about all of these projects, was how do you introduce these things to really young students? Anyway, that's as easy as it gets. What's next there?
We've got a few other projects that we're actually going to be able to show you in real life. So again, putting in the context, what we decided to do was start with something that could be used by K to 7, with the idea that, yeah, there's going to be a small cost up front, but if we can build group kits from it, then that would be great. So the idea that you can use the same materials and the same tools over and over again across these projects. Many of them are also designed to be take homes, so low cost, but easy for kids to take home. We put, as much as possible, we put that thought of, okay, what does this look like on its own as a project? But more importantly, what does this look like when you've got 24 kids working on it at the same time? So a lot of the resources in the book are maybe familiar from other places that you've seen on Pinterest or wherever, but know that when we put them in the book or on the website, they are undertaken under that context of, okay, scaling this up. Currently, we don't have kits built. I would reference the Learnery. You can definitely check out their stuff. They're building some kits that you can pre-purchase, and so you can take into the classroom. What we are going to look to do with a lot of these projects is say, okay, if you're looking at a class set of materials, here's what it's going to cost and what it's going to look like for 24 students. Or if you're trying to take this on as like a bigger thing, here's what a quick kit that you could reuse over and over again is going to look like, and here's the consumables you're going to need to invest in every year. Really trying to make that electrical kind of experience accessible to kids. How many projects did you create in total for the book?
I think there's 17 of them.
Okay. You made 17 projects?
I think so, yeah. And then Alex gave
cool.
us some Circuit City ones, which are still includable. Yeah, there's tons of them to choose from.
Well, that's exciting. I thought there was only 15. So the 17 plus the others that are, okay. Well, keep an eye on the
included the Circuit City ones. Yeah, keep an eye out. There's lots of them.
Perfect.
And maybe the ones that don't make the cut for the book, we can just put up on the website anyway.
Oh, there you go.
Yeah.
If you have project ideas, you want to submit them, please do. Okay, I feel like we're selling something that is free. I'm going to put in the chat now. You're going to find that SurveyMonkey link. So if you do want to register for any of this or get a copy of the book when it's out, please check it out there. We are going to probably release the final version of the book by printing. Everything's about 2 months behind, so January, if at the earliest, when we get it back. Jesse, I'm thinking we could switch over to the live projects now.
Sure, yeah. Have you
So
got the energy shake there?
Yeah, this one is, okay, full disclosure, it's the most awkward project to demonstrate. So bear with us as we switch camera and get shaky.
So grade 7s in this case are learning about how electricity is generated, and at the very basic level, it's commonly generated with magnets moving relative to wires. So this thing doesn't have any batteries in it. It's just magnets in a tube, and you've got the coils of magnet wire or enameled wire over that. So tapping into the motor winding side of things. This is a really straightforward project, but as the magnets move past the wires, we've got a little LED on it. I don't know if it's going to show up very well.
No,
in
I
this-
have to shake it really hard. So I
Yeah, you-
apologize in advance if this makes everybody a bit nauseous, but you shake it long enough, it'll actually light up. There it is.
It's lighting up.
Is it showing across?
It's not super bright. I did
All
see it. Anyway, it works really well in a dark room, and it's like magic. Anyway, what else? Oh, I really wanted this to give kids a creative idea of how to make electricity. Anyway, there's the next one. This is a tiny, simple switch. It's a little card with a light up LED in it. Kids can design whatever they want on the front or do a collage, but can you guys see it lighting up? The little heart on the bunny? Anyway, introducing the idea of a simple switch to turning the lights on and off. Pretty straightforward. The next one.
I'm gonna pull this out as a bag. So this is,
Oh yeah. This is another one using the stainless steel conductive thread. Those are the little templates. It comes as a template so you can print it off and then cut out the shapes. But you've got a little switch in the tail. So when you push on the tail, the eyes light up. And they're pretty fun to make. You can do it cross-curricular and teach them about marine biology at the same time, whatever. But anyway, learning.
that was definitely a consideration with highlighting, which is like a lot of these projects fit naturally into the math and science curriculums first and foremost.
Yeah.
But the fun part about it is, like we've been talking to a few educators about the ways that they would integrate these things into even English or history.
This one was one of my favorites.
I've been playing with this for 10 minutes and I still can't get it. First try.
You can't complete it without turning on the circuit.
No.
This is a take on operation. The kids can design whatever they want to. We've got end caps, copper end caps, and nuts in behind the photo or behind their drawing, and they're sitting on aluminum foil. So if you accidentally, as you're trying to pick these things out, connect the needle nose pliers to the metal behind, then the little LED lights up. If you can see the red, yeah, there you go.
Now it's actually working.
So there's also a resistor in there, so kids get the idea of having to include resistors. You can take it really nerdy and take it into high school and measure the actual electricity going through that, or you can just have a fun game to play with elementary school kids.
Yeah.
When we brainstormed pick the booger, that's so brilliant. I love it.
I think back to that one for just a moment, the pick the booger. The kids are learning how to use needle nose pliers without even realizing they're using a tool of the trade. And I also thought it's kind of fascinating to teach them that tools can be conductors. You know, like it's really important that you have your circuit off while you're working on it, because it can go right through the tool that's in your hands. Anyway, another little safety tidbit in there.
Yeah. One of the things I highlight as we were planning all the projects that we talked about costs and reducing costs. So like you'll see a lot that we use like the AA, like 3 AAs, or we'll use 9 volts in the other projects a lot, trying to keep as much as possible the consistency to it and not adding a bunch of random extra costs in for resistors and LEDs. So in some cases, if you can find incandescent lights, we recently discovered that we could go to Salvation Army and get a bunch of old Christmas lights that are incandescent and cut them apart, teaching kids how to strip wires. And also they're like a 2.5 or a 3.5 volt light. So often we can get away with two AA batteries and it's good times. With this one as well, Jesse came up with this brilliant idea. Also shout out to Heather Elliott, who helped us originally with some of the projects. She introduced us to scrappy circuits. So what we realized was that you could get kids making their own alligator clips, especially for like the lemon battery, which we'll introduce in a second and stuff.
Oh yeah.
But they can make their own alligator clips. These are just binder clips. That's what they're called, binder clips.
Mhm.
And then some wire. We've been using a lot of thermostat wire. This is like I think this is an 18-1 like just a single gauge wire, but we've been using a lot of thermostat wire because you can get like it as 16.2, 16.3 or 18.2, 18.3, so you can simulate home wiring or commercial wiring without actually electrifying yourself. All right.
Fruit battery?
Okay, so I can't get it to work, but
Okay.
we'll put it out anyways.
Oh, beautiful tray.
Thank you.
Shout out to Renee.
Hey, Riley.
Um,
Master Tyler, another project. This is actually 3 projects in one. The copper handle, which kids can take home and install on their dressers and such.
yeah, see the Skills Ready website for that one too. I gotta flip back to the fruit salad one. Okay, so this one you can either use to light up an LED, or you can hook it up to a multimeter and read the voltage of it. And you can hook up. Oh, it's very faint, but I see it lighting up.
All right, let's see if we can read. This is not a camera that can focus that close. So I'm gonna, you chat. I'll see if I can find it.
Okay. Usually I have this one hooked up to a multimeter. So it teaches kids how to use a multimeter and they don't even know they're learning it because they're trying to figure out which of these foods that they're hooking up actually produces the most amount of voltage. So if you have a copper and a zinc electrode, in this case, a roofing nail and a chunk of, oh, there you go, and a chunk of copper wire that you've stripped, you can hook up anything. And the bottom left, we've got some spicy tuna sushi. Oh, the multimeter got cut off there, but it actually did produce some voltage on that. So
The
kids
watermelon
can,
did not.
the watermelon had nothing. And that's really, really fun in a science classroom to have the kids making hypotheses about which of these are going to have the most voltage and then testing it out, and then even graphing their data. They can be noting down the voltages, like does every lemon have the same voltage, all that kind of stuff. Do you see it?
Well, it's an anticlimactic moment. As you can tell, we have some fairly low production value to like a Steven Spielberg, but I'll make a video and share it with everybody so you can get as excited as we are.
Anyway, the highlight for that one for me is that kids are using multimeters. I remember learning about multimeters in physics and just being so bored with it, but this is a lot more fun. Cool.
So
I think that's all of the elementary ones.
I do believe so, and I think
Okay.
that this is an excellent moment to transition to the next project. All right. So again, summarizing that 17 projects, I think 15 are in the book right now. We might expand the book. We also have some career highlights in there. So if you're looking at the tie between motor winding, for example, and a career, you can show kids that it's actually a thing. We have one of our career spotlights, or career bites we call them, is going to conclude the meeting for us in about 15 minutes. So again, it's an intro to tools, but we do want to give teachers the resources to talk about trades as well. Am I introducing the next? I think I'm introducing the next project.
If you'd like to.
Sweet. Okay. It's a very brief origin story, but a long time ago, we were having a conversation around what we could do to make trades more obvious to school students. And what we realized is, as long as they were living in a shop class down the hallway, students were always going to see it as an elective or an exception, or for those kids down there. So what we were trying to figure out to do was to bring applied learning and trades learning into core curriculum and use project-based learning as a delivery mechanism for some trades discovery, kind of sneaking in the tools, sneaking in techniques, sneaking in theory as the soft introduction, and then having these projects tied to careers as like an obvious connection. Also, it's that idea that you can be an engineer, but you better know what you're doing so that what you design is that much better. One of the things we've been looking at for a while also is how we can create an applied graduation pathway. So how can a student in grade 11 who doesn't want to be in a classroom get involved with hands-on learning, doing the work experience piece, doing the youth train and trades and youth work and trades programs, and really building their last 2 years of graduation as a transition into the world, and being as busy as they can making things. So what we did is we looked at what courses we could create. We said, let's bring 3 courses into the period of time that it takes you to do 2, so that we could do this as a summer project. And we thought, let's do a math 11 and a physics 11 and combine it with an electrical 12. Because we knew Stu Wheeler, and we're like, Stu's got this covered, we'll just throw it in his classroom. I then discovered that electrical 12 is only a Victoria School District thing and a few other board authorized courses around the province. So we abandoned the idea of the electrical 12 and we kept it sort of electronicsy. But Jesse spent, I don't know how much of your life building up a curriculum. This curriculum is now available to anybody. We built it as 12 modules. Am I stealing your thunder now?
This is really cool. Yeah.
So we built it out as 12 modules. Each module has at least a priority to physics or math, and it can be integrated into a math 11 or a physics 11 classroom, or it can be undertaken as one big course. And if you have an ambitious classroom and you want to include something like engineering 12 or electronics 12, or even phone up the Victoria School District and say, hey Stu, how did you build out your electrical 12 and how can I turn these projects to match that? Then you can do 3 courses in one. Again, this is about making core teachers see projects and trades as something they can bring into their classroom. So we do want to encourage shop teachers as well to become maybe some co-delivery stuff. If you want to take this on in your district, give us a call. We are looking to pilot it. We might have some resources hidden away to do that. And we'll go from there. So Jesse, where do you want to start? Do you want to start with pictures or do you want me to pull up projects?
Let's start with a couple of the pictures. There were a couple other little bits into an intro that I wanted to mention too. When they gave me the idea to this, it occurred to me that Physics 11 and Math 11 are the 2 highest academic courses that students need to get into the electrical programs at the colleges in this province. And those are really tricky courses. I've taught them. They're very academic. They can be very dry. And so I was so excited about this idea because can we teach it through electrical projects it's a massive challenge. There's all sorts of stuff in the math and physics curriculum that has nothing to do with electricity. So these projects, they're quite wide ranging. There's all sorts of stuff about sound, the characteristics of sound in the physics curriculum, and stuff like financial math in foundations of Math 11. And so it's very wide ranging and it draws everything in, but we tried to keep it really tight to electrical stuff. So I think that's all I was going to say for the beginning. Yeah, let's look at some of the pictures. I'll show you some of the projects. Okay, this one, let me explain what's going on. You see a battery box on the top left. And on the bottom right, there's a little motor that runs, and it actually runs a wheel, and it brings ball bearings from the bottom all the way up to the top, drops them into that white cone, and then they flow through the tubing. And they actually, because they're conductive themselves, they light up little lights and make little noises on their way down, and then they get dumped down into that little tray at the bottom where they get lifted up again. So it's this kind of motion machine, but you can actually attach, and we show you how to do this in the project for the teachers. You can attach a multimeter to it, and you can calculate how much current and voltage this thing is taking, and then you can compare that amount of power to the actual energy, the potential energy that the balls gain as they go from the bottom to the top of that. And then you can use it to calculate the efficiency of these little motors that you're using. And you can get super nerdy with it, or you can just make toys out of it, which was the most fun about making this, is because you could use this with maybe grade 8s if you wanted to do a giant fun one, or you can apply all the math and physics to it. So that's one of them. This one is, there's a tiny little gear motor there under the bracket, and you make a hub, and then you clamp that to a table, and you attach a weight to that ribbon. And then as that pulls down, the gear motor turns into an actual little generator. And so all those little wires that are attached to the left, you can, again, put a multimeter to that and see how much voltage and current is produced. And you're basically just using the different energy formula to compare how much electrical energy you're getting out of that and how much potential energy the object has when it's up at the top versus as it's falling. Anyway, you get kids to measure it, video it. Oh, this is one of my favorites. So in an old-fashioned physics classroom, you have the ticker timers where you have the little buzzer and the tape going through, and you use it to kind of quantify acceleration to gravity or movement of horizontal, like cars across tables or whatever. This is an updated electronic version. So what you're looking at is an Arduino microcontroller at the back, hooked up to this little ultrasonic sensor. So it's using little pings of sound waves. And anyway, you can use that to track objects. You can actually, it comes with, sorry, I'm getting ahead of myself here. We had someone come up with the programming for that. So you can hook it up to your computers and you can have a readout of what the movement is doing, of the little balls that you drop in front of it or cars that you drive across a table. And the readouts are right there. The Excel spreadsheet template is there. So your students can just download that, put this together, and voila, it's nerding out on your objects moving. Right.
Also probably our most ambitious in terms of like a introduction of technology, because there's some coding and Arduino stuff in there.
Mm-hmm.
But what we thought as well is a great introduction or way of talking about some of the careers out there, like instrumentation and control technician, even aspects of what electrical is becoming, even in the low voltage side or elsewhere. So it is sort of base skills that they're going to see across a couple different trades.
Oh, this is one of my favorites. This is a little solenoid, again, working in the motor winding, and it shoots magnets when you hook it up to a 9-volt battery. So this kind of covers all of the motion of projectile motion, and it covers the math of quadratic equations. So kids can build this, record it, come up with their own quadratic function that describes the arc that their magnet flies in. Anyway, it's really fun, and you can go as nerdy as you want to. This one, it covers, it's called Heat It Up. It covers the specific heat capacity of water. And they're heating up water. They're looking at the temperature change. You can get them to make different types of insulating water containers, what works best, design a scientific experiment around it. That's a pretty fun one.
So we're just conscious of time.
Yeah.
And so there's 2 other projects to sort of show through. I have here in front of me.
Oh, the acceleration one?
Yeah, so the one I have set up first is this one.
Oh yeah. Okay, this is a simple motor. You've got your 9-volt battery, you've got your magnets, and you've got your circuit going all the way around. And then the kids make this tiny little sort of winding of a coil of wire, and hopefully it starts spinning all by itself. So that's how a motor works. And super straightforward. You can even make your own connector wires with that. And you can work on getting them to make attachments for it, so it actually does something. You can have it wind something across the table, make a little fan. Anyway, that's one of my favorites. Yeah. And then this second one that Jordan's bringing in here, this is a hobby motor with a hub that's attached to a switch. I don't know if you can see it spinning there, but who doesn't like to play with toy cars? That shoots the car across the desk, and you can shoot it between 2 meter sticks and video it, and then the kids can quantify it, make graphs about how the car accelerates. Yeah, that one I like. I like both of those are, I think, my favorites. Anyway, thanks for showing those, Jordan.
Welcome. So, and again, a lot of these are very like electronics focused, but the concept is as much as possible to integrate tools and techniques into the actual process of making the projects. So there are resources in the modules themselves that then identify how that works and then ties a little bit into the career piece.
Videos of how to use the tools and stuff to put them together too. Yeah, it's hard to describe all that in this short amount of time, but
we highly recommend registering on that SurveyMonkey link, and we'll send you copies of the module as well. I think these modules are all online, or a lot of the projects are online, and the modules will come out next week. Is that the plan?
they're coming up. Yeah,
Perfect.
coming online. Are you talking about electrical discovery?
No, do you want to
Great.
transition to that one?
Sure. Yeah.
All right.
Do you want me to talk about it?
I was
You
just going to
set it
shout
up?
out the ITA because they were the ones who suggested that it would be possible to create some projects that were electrical discovery. So one of the things that we have been doing for quite a while, as many of you know, is working on projects that really promote the trades, like Project Shop Class. So I thought I froze for a second, but I didn't. It was just everyone was listening intently. So what we've been doing is looking at kind of starting with a trade idea, looking at a project that can introduce that and either introduce an element of it, like a process, like a technique, or a tool of the trade. We've also been building up a little bit more ambitious projects because we realized not everything could be boiled down into a 90-minute intro. So we have these kind of classifications of projects that are a little bit more advanced or sequenced. And with electrical, we've been playing with what's the relationship that we can bring into something that's real so that we can start with introducing safety in like home electricity, but also not just do the science projects, but also kind of show people what's behind the walls. So there's 2 projects that we'll be putting out. Neither of them are something that you would take on if you've never touched the tools before as an educator, but they're definitely accessible if someone's committed to learning them. Jessie, is there anything else to highlight with that?
I think that just to highlight that risk shouldn't be a barrier for a teacher to introduce these skills to kids. This is hooked up to a 9-volt battery, really low voltage, but they learn all sorts of skills like cutting the wire, stripping the wire, hooking it up to the light switches, mounting the junction boxes, the utility boxes, and it's all set up so that you can test it with a 9-volt battery. So you can test your skills, you can mess it up, and you're not going to electrocute yourself or your students. It's all the safety is the first concern in that case. So what else was I going to say about that? Yeah, you're basically modeling house wiring with a safe amount of voltage. So I think teachers would be comfortable taking this on and yeah, introducing those skills to the kids.
Again, this is one where if you wanted to take something like this on and you're like, I need some help, you could always call Renee, who may have a volunteer presenter here and there who would come by and help you out, or perhaps Lindsay, who may have a volunteer presenter hiding here or there to come help you out, or maybe Lisa, who is herself maybe willing to come by and help you out. So again, this is something that we designed with the idea that if you had a tradesperson, even as a parent volunteer, and they're looking for something that they could do, it's relatively affordable. This whole setup, it cost us about $22 to make the board. We may have got a sweet discount, and some of it may have been laying around my house already, but it isn't remarkably expensive. Plus, it's all reusable except for the wire. This is our first version of it. We've been this is our last version of it. We've been demoing a couple different ways. Some really key things is that it's actually 3 separate projects. So you have the first one, which is the simple flashlight project, we call it. It's a regular house circuit. We're using thermostat wire. We have the junction box for teaching how to splice, and the battery itself is just a 9-volt that clips into a EMT clamp. I don't know where all of our 9-volt battery caps are. I think somebody on this call has borrowed them and perhaps has them all. But it's super simple. So that's the idea, is that they can build just one that takes about an hour. It took me 2 hours to make the whole board, and I did it wrong 3 times. But it's a great way of also introducing kind of why things go wrong, because you get to do things like short stuff and whatnot. So simple circuit is the light to switch, and then the more complex one is this is a motor, and then this is the Christmas light poking out of the metal box. The idea with this one is that you can have them all on at the same time. It's parallel, but so you do lose some power. And yeah, we put the face plates on it so that it's just like real life. The third box is we've been talking about how we make this more of a design challenge. So what we wanted to do is not make this super complicated for youth or for adults even. But so we introduced very simple wiring, a little bit more complex wiring, and there's lots of places to mess this one up. So you, like Jesse and I have both, in making it, managed to have the light up, even if the switch goes on and off, because we of course wire it to the source. And then the third box is a mystery box. So it ties to something we call deconstruction station, which is where you could take apart a blender to find magnets and wires. You could take apart Christmas lights, kids' toys, whatever it might be, to find those components of it that actually make noise, make light, or move. And so the idea is that they get to design their own circuit from this box onwards, again, tying into the source, and then they can mount it in whatever way they want here. This is a 3/4 inch piece of plywood, cut to 2 feet by, I believe, 18 inches. Need to double check that, but yeah. Super simple project. A more advanced version of this is something that we're using in the Trades Gateway, which is a 3-hour project led by an electrician. And in that case, you're dealing with 2 receptacles and a switch and a light and a homemade extension cord. So this is the gentle introduction. We would intend this to be something that you would buy, as a group set of boxes. So you could buy 60 boxes for a class. Kids could work in pairs, especially because there's a lot of moving parts. You can lay out the whole thing first and then wire it up. But the idea would be that you take it all apart, take every piece, put it in its box, put it away till next year, or take it to the next classroom. The only thing, again, that's a burner is the wire. And I'm sure you could donate that to the elementary projects and they would make use of it as well. So that's all of the projects that we have to show you today. The box below my feet we didn't get to. They're all going to be online on the project website. Again, that SurveyMonkey link is to sign up for whatever you want to see. We're going to do 2 things. We kind of talked a long time, so we're going to introduce Lindsay, and I'm going to get out of here, and Lindsay and Jesse are going to have a chat. We will stick around past 4:30 for questions. If you have questions that you want me to answer right now, throw them in the chat. I'll keep an eye on that. But yeah, I'm gonna switch out of here. And hi.
Okay, what does that mean that he just said hi? Supposed to talk now?
I guess I'm gonna ask you a few questions about you.
Okay,
Hi,
I actually
hi.
do have photos here that if it's okay, I can share my screen.
Please do.
Okay. Here we go, because it's a lot more exciting than staring at my face in my messy office. Look, I'm up a ladder. Hey. One of the few times you'll see me wearing a tool belt, because one of the things I learned pretty rapidly in the trades is you got to protect your body. And so I actually would always try to avoid wearing a tool belt because it is hard on your body and you need to be centered, and it's hard to do that with things hanging off. But when you're up a ladder, sometimes you really need to have a tool belt. So anyway, Jesse, do you want to interview me, or what would you like? How would you like?
Sure. I guess maybe I'll ask you some of those little questions that we're going to have in your career bite in a little bit. But essentially, what trade are you working in? Well, and can you briefly describe what kind of specialty role you might play in that trade?
Sure. So I'm coming to you today from Lekwungen territory, which is the land of the Esquimalt and Assangees. And my name is Lindsay, and I'm an electrician. I have my red seal. I am a journey. And I just spent 10 years working in construction sites around sort of the greater Victoria and Southern Vancouver Island area, as well as I did a lot of work in various TELUS buildings around the province, because From the beginning of my apprenticeship, I actually specialized, which is sort of a rare choice. A lot of the time we're supposed to become well-rounded tradespeople, and I decided not to do that. I got into doing building automation when I was very early on in my apprenticeship, and I loved it. And I decided that's what I would do. And so I did my entire apprenticeship in working in this one specific niche. And for the most part, that was a risk that I do not regret taking at all. The only time it was sort of a bit of an issue is when I did sit down to write my Red Seal exam. The questions are based on being a mainstream construction electrician. And so like the very first question was about installing staples for different types of Lumex. And I laughed out loud and people looked at me in the exam room and I was like, sorry. I just was like, I literally don't know the answer to this question. And there was a few little things on that. And, you know, I mean, I sort of laughed with the instructors afterwards and we were talking about how the exam had gone. I said, well, yeah, so I think I passed, and I did. But yeah, if someone's going to ask me for like my mark on my IP as being, you know, an indicator of my skills as an electrician, no, it's not representative. And that's one of the things I like to make sure people know is that the electrical trade is incredibly vast. There are so many amazing niches. There's such a variety of work. There's so many cool things you can do with it. And so what you think of maybe as being an electrician is actually probably just scratching the surface of what it is to actually be in that sector.
Fun. It sounds like there's a lot of different opportunities in it. I was really, one thing that I'm really curious about is, because you talked about applying staples, or I don't know what are some of the tools that you use in your specialty as a specialty electrician? What are like your top 5 tools or something on your tool belt there? Like, okay,
that's a really good question. Thank you. I did actually, and now that you're saying that, I'm like, oh, there was one tool that I meant to grab and I didn't. Because I did actually bring a few tools here just that I keep in sort of my go bag when I'm running out to do things. Do I have a little one in here? Okay, so first off, and I'm sorry, I was sharing my screen, but I actually can't flip through the photos and I don't know why, so that's a bit odd. Okay, the number one thing being a controls electrician, I do like a multi-driver. A multi-driver is fantastic, especially, so a multi-driver is a screwdriver that you can take apart and has all different screwdrivers in it. And I have to tell you, the reason that I learned about these is because I was working with a journey person, JP, who was wonderful, and it was really early on. And the thing he said to me is, so we are on rooftops, we are crawling around in weird tunnels and crawl spaces. Building automation stuff is all about valves and relays in strange locations, boiler rooms, mechanical rooms, data rooms, tunnels, rooftops. That is my world. And guess what? You lose things constantly. So you use a multi-driver, so you have what you have when you want it, but you buy the cheapest multi-drivers and you always have at least one spare. You keep it in the van or wherever you have your stuff. And then when you drop this down that duct and it's actually 3 stories below, you're like, oh, well, and you pull it. It would be really great right now if I had a second one. I don't. And you pull one and it sucks, but it's so much easier than getting wrapped up in having one specific tool that you're like, oh, this is like the one I'm going to have forever, because it's not realistic. Sorry. So multi-driver. And then this is a 4mm. No, yeah. And so what this is a this is a controls driver. I don't know if you can see. This is a controls screwdriver. It's a tiny flathead screwdriver. For securing tiny wires, this is what you need. It's comfy. It's not going to hurt your hand to do this 7 million times a day. When I started out, I'm not kidding you, I used to use these a lot, and I will still keep this in maybe my shirt pocket. It's a tiny little sort of disposable one, and it has, like, you know, there's the flathead, and there's the Phillips, and it's great because it fits in your pocket and it's nice, but this will kill your hand when you're terminating hundreds of wires. And so, yeah, a nice Vera brand, their German brand. Yeah, this is one of my favorite things. But then the thing I actually really want to show you is not actually a tool specifically, but it is a tool for how to be a good apprentice. And this is something that I tell anyone who's educating apprentices, anyone who is an apprentice. I was just at the International Brotherhood of Electrical Workers Women's Conference in Toronto, and I told so many apprentices there about that. And that is a notebook, your contact information, who you work for. Every single job at Esquimalt High School, you put in, I did a lot of renos at schools and stuff like that. You put in all of your information. You make sure that you write down the job number, and you write down, let me see if I can find a good example. Unfortunately, these are, it's a bit faded because they're old. But this is one of those things that, like, I always try to tell apprentices, you need to be in control of your own apprenticeship. It is a really intense career in that way, that you actually need to advocate for yourself, and you need to have an idea for how things are going to be happening, because everyone is so busy. There's so much pressure to get things done that it's not going to happen.
Would you say that that would be your biggest piece of advice for someone considering a career or an apprentice?
And it's things like, okay, so here's, so you always put the name of the job. This is EHUT at UVic. You put the job number, you put your questions, you put your information, you put the name of who from other companies is working with there. You put their phone numbers, and then you start tracking things. So here's a whole bunch of stuff where I was calculating.
We're running out of time here. Oh. I'm sorry to cut you off, Lindsay.
Sorry.
I think that we talked for too long before you, and I apologize for that. And I could talk to you for hours about what your job is like. And I'm wondering how people can get in touch with you if they are curious about becoming electricians.
Great question, thanks. I am actually off the tools right now. I left almost 2 years ago in what was supposed to be a temporary gig that has sort of continued. I work for the BC Centre for Women in the Trades, working on equity and inclusion issues for supporting underrepresented people in the trades. And I love the tools. I miss the tools. I'm still in touch with my crew. I was talking to one of them this afternoon. So, I always try to keep that door open, because it's just, I still feel like that is my life, but I have this whole other sort of set of work that I'm doing right now, which is on building leadership skills among women in the trades, trying to connect women in the trades with one another, and also making sure that anybody who's going into the trades understands that these are fantastic careers, and there is a place for you there. And it's not just one certain type of person that belongs in the trades, but there's a place here for everybody. So here, I'll put my email here.
Thank you.
But yeah, I'm at lindsay@bccwit.ca.
Thank you for all of your enthusiasm for this. I wish that I could drag you through every classroom in BC and show everybody how much fun being an electrician can be. Jordan, I'm not sure how to wrap things up for you there, other than saying thank you to Lindsay for being so awesome and helping us out with. And
yeah. I kind of wish that we just let Lindsay talk for like 45 of all of them.
I know.
I just wrap up a quick, I'm gonna quickly throw it to Renee. So a lot of what we're doing this year is outreach. We're doing a lot of presentations and workshops. Renee, do you want to quickly just share what how to get a hold of you and what's going on there?
Sure. So yeah, as Jordan said, I personally am doing presentations and hands-on workshops around the province. Obviously, I'm based in the Lower Mainland, so that's the primary focus, but lots of stuff on the island, in the interior and the north. I love putting together road trips, so give me an excuse to drive around. That would be great. But we also have a fantastic team of tradespeople, and some of them are now comfortable doing their own presentations on their own, which is great. Many of those, there's quite a bit of overlap with BCC WIT. So, you know, there's a good community of passionate people like Lindsay, who we can draw on, not just in the electrical trades, obviously, but across all trades. So I'm happy to facilitate, you know, presentations. By that, I mean, you know, kind of more a stand and deliver kind of thing. And we try wherever possible to bring in hands-on. Sometimes it's just a demo, but wherever possible to have a short project, anything from, you know, 5 to 45 minutes that can be done in a single class. So Jordan, I don't know if you want to just put up there, renee@skillsready.ca, and either, you know, we'll figure out something that works. We can customize it to what you're looking for, depending on the age range. This year so far, I think the youngest class that I've had was a 3-4 class, and, you know, all the way up to not just grade 12, but even we've had a number of community groups and adult groups and stuff. So, you know, whatever works, we'll make it, you know, we'll make it so that it is most impactful possible.
Yeah. So again, thank you for everyone's time today. I think that's the shortest run over that we've ever done, probably because we didn't let anyone ask questions. We will hang around for a bit and turn the recording off and have a chat and ask questions. To notice question, yes, for the workshops that Renee does, all of the materials are brought with him as well as the tools. Yeah, so again, thank you to the ITA for helping us out and making this possible. Thanks to Lindsay for your time today and for for inspiring a few of these projects yourselves. Yeah, Jesse, thank you for writing it all up and putting it online. If you do want to hang out, that's fantastic. We'll see you soon, or if not, we'll see you soon.